Hello everyone. Let's understand of how to reverse a given linked list in this session. There are two approaches to reverse a linked list. One would be the iterative method, the other is a recursive solution. But what we will look at is the first approach of doing this task iteratively. And we are also looking at an objective of not creating new nodes or dummy nodes in the process. So we will reverse the given list by just changing the links. What you see here is a linked list with 4 nodes with the data fields in each of the nodes in sequence being 10, 20, 30, 40. And after reversal, I would want the sequence to change from this series to 40, 30, 20 and 10, right? And we also understand that this variable first would not have the address of this node 10, right? But rather it would have the address of the node 40 as the first, right? So there is a change to the variable first. So what I see is a transformation of this original linked list to something which looks like this, right? So after the reversal, I would want the first element to be this node whose data field is 40, and then that should point me to the node whose data field is 30. Then that will lead me to 20 and 10. So as you can see, 10 should turn out to be the last node of the list, and hence its next field should be null, right? So let's get started to write the code for this linked list. So let's come back to the original list. We will see of how I will reverse it. Right. So all of us remember that we always used temporary variables to help us traverse the linked list, right? We called it temp, we sometimes called it current. In operations like deleting before a given value or inserting before a given value, added to a current pointer, we also had an additional pointer called priv to remember the address of the node which was just before the current node, right? So let's assume initially we also in this routine have only two variables, one which is current and the other one which is priv, right? So let's assume we start from the first node, and that's the only address we have right now, right? So let me initialize my current to first, and which is basically the address of the first node. And what would be just previous the first node? There's nothing, right? So let's assume the node before the current node is null, right? So what should I do now? I should understand the fact that the next field of this node where current is pointing to should lose this value 2000, which is the address of the previous one, sorry, the next node, but it should become null, right? So it should become null, so that this turns out to be the last node, and I should move to the next node. So I should have my current move from pointing to this node to the second node now, right? Which, but how do I achieve this, right? So I have lost, see, the node whose data field is 10, it has lost the address of the second node. So what we are trying to understand here is probably with only two temporary variables, current and previous, we may not be able to complete this task of reversal, right? So what we will do is we will bring in one more temporary variable, one more struct node star variable to complete the task, and this is what I call successor, right? Let's have one more variable, successor, which will help us complete the task. So let's start afresh with three variables now, but they would be called current, previous, and the one after current would be successor. Okay, now the initialization of the variables current and previous will remain as is. So let's write a routine reverse SLL, which takes the variable first as an argument, and let's have these local variables declared, right? So it would be struct node star current, struct node star priv, and a successor right? Okay. We have the three variables. Let's initialize them. So as was done earlier, let's have current point to the first variable and previous is just before first, or initially it is null, right? Okay, so I have no clue about the number of nodes in the linked list, right? So always a while loop helps me traverse the entire list, right, or visit all the nodes. So let's have a while loop. While loop. Let's put the condition later. Let's do the job of traversing the list within the while loop. Yeah, and when I traverse, I will also have to make sure that the links are also appropriately updated. Okay, so initially this is my current, my previous is null, right? So let's get into the while loop. So what we were trying to understand is I don't want to lose the address of the second node. So I will say this is the successor. So let me have successor hold what is in the next field of current. Yeah, I will say the next of current, which is basically this node whose data field is 10, right? So it should no longer, I should get rid of this arrow, right? So let's get rid of this arrow and let's say it should become whatever is the value in previous. So this will become null. Okay. Now, as you can see, successor holds the address of the second node and I have not lost it. Correct. So I will say priv should become current. I'll say priv should no longer be null, but let's have previous hold the address of current and let's promote current, right? So let's say current, you don't remember the old value but remember whatever successor holds, right? So as you can see, with these operations I can remember of who is after the current value. I also remember who's before it. Yeah, let's do these set of steps again, where I repeat, step 1 would be to get successor move ahead. So I will say successor is equal to successor arrow next. I will say currents next should be, let me take out this address or basically take out this arrow. I will say currents next should be whatever temp is priv is pointing to. Where is priv pointing to? Priv is pointing to this node. So I will say, okay, let me have this link established and I will now move ahead my previous and current variables, right? So I'll say, okay, if current has to move ahead, it has to give its value to previous, right? Otherwise I'll lose it. So just going or taking one step ahead the current variable, I will lose the address of the second node, right? So what I will do is I will say, okay, previous, hold on, don't hold the address of this, but now hold the address of whatever current is pointing to. And the next task would be to say current, don't hold the address of this but hold the address of this node, this successor. So I as you can see, all the three nodes are basically moving just like a sliding window, right? And thereby in the process of moving they also changing the links, right? So let's fill those statements in my while loop. So I had my successor move ahead. I said successor is equal to go to the next item. I changed the link of current. Current is the node where I am standing. So I want its link to be no longer successor but to become previous, right? Because I want to reverse the linked list. So I will say current next should be whatever is held by the variable priv, and I should also update my previous. Please remember this is the order in which we would do so that the addresses are not lost, right? So I update my previous to hold whatever is the current value of car variable, and I will also increment the current variable to whatever is held by successor, right? So I keep doing this, and when should I stop? Yeah, let's come back to the diagram to see of when I should stop. So I will reach a point where the links would have changed. So let's say this link is lost and I have my link established like this, and I want this null also to go, and I would have this to be the updation, right? So when I am standing at current, right, let's say this is my current and this is my previous, I would want to stop, or I would want to stop when current gets a value which is null. So my successor would have become null. And look at the while loop, you put the value of successor to current, right? So the moment you have current becoming equal to null or current also becoming null, you would want to stop the while loop, right? So which means you have come to the fag end of it, right? So while current not equal to null would be the condition which should go into the while loop. And as you can see, there is a change to first, right? So till now in my entire code I had my first have an address of 4000, right? So this was the address of the first node, so I had the variable first hold the address of 4000. But as you can see, it shouldn't hold it, right? So it should now hold the address of the last node. And when the moment priv became null, current became null, I had my previous hold the address of this node whose data field is 440, right? So I will have to make a final statement where I ensure that first will no longer point to this but will point to this last node. And who has the address of the last node? Previous, right? So our assumption is that first is a variable declared in the calling function or the main function. So let's return previous, basically the address of this node to the calling function, so that the calling function would have a new value for the first. And as pointed out, the return value of this routine reverse should be struct node star, right? So what we've understood is that with the help of three variables, we have a linked list being reversed iteratively in this code. And there's a change happening to the variable first, right? I would want to conclude this video with a quick animation. So let's quickly go through this. So you see that there are 5 nodes here, and all are expected to be reversed. So 1, 2, 3, 4, 5, I want it to be 5, 4, 3, 2, 1. So there are 3 variables as discussed which are being used, and they are initialized with previous being null, current being the first node, and the variable successor in our code is called next here, right? So if you could see, there is a kind of a sliding window movement happening, right? And the last part, when you come to the last node, you have successor becoming null, current also becoming null, and that is when you stop and you have reversed the list, right? And we should also make sure that the first node is updated, yeah, would get the new value of the new first of the linked list. Yes, uh, I hope I made it clear with this video of how a reversal would occur of for a given linked list, and many more operations to be learned in the upcoming videos. Thank you.